So today we covered two topics in lecture. The first was hydrostatic forces on curved surfaces. The approach to analyzing forces on curved surfaces is to think about an aggregated force balance in which the curved surface becomes the boundary of a fluid analysis. And so I'm just trying to sketch this here. The boundary of the fluid then becomes what I'm outlining in red. And we think about the forces that are acting on that fluid. So we have hydrostatic forces from above, hydrostatic forces from the left. We have the weight of the fluid acting downwards. And then finally we have the force of the wall acting on the water. And it has magnitude of the hydrostatic force that's the same as the fluid that's exerting on the curved part of the wall. So then we just consider each of the components. So if this is the hydrostatic force acting from the left, this is the hydrostatic force acting from the top, then the solution is that the hydrostatic force in the x direction, or the x component of the hydrostatic force, is just equal to the force coming from the left, and the hydrostatic force acting in the vertical is equal to the force coming from the top plus the weight of the fluid. The one special case we talked about was for a circular surface. The line of action is through the center of curvature. So a circular surface, F hydro, the vector acts through the center of curvature. Wherever that might be. All right, the last topic we talked about in this unit is buoyancy. Buoyancy is this upwards force that is acting to keep solid objects perhaps floating or reduces their sinking speed, and we'll talk more about that when we talk about drag forces later in the term. But basically, the buoyancy force is equal to the specific weight of the fluid, I'll just call that gamma F to be clear, times the volume of the object. Whoa, okay, let me just write that again. The force of buoyancy is equal to gamma F times the displaced volume of fluid. The way we derived that was we thought about the pressure forces that were acting from below, that the pressure forces are greater than the pressure forces acting from above, and that force which would have gone into supporting our fluid in that volume is now going into supporting the object. And that creates the buoyancy force, which is described by the weight of the displaced fluid.